I'm here to present my topic, cybersecurity. So, cybersecurity is actually the ability to protect or defend the use of cyberspace from cyber attacks. Cyber attacks are actually destroying the integrity of the data or stealing the controlled information. Cybersecurity is important because government, military, corporate, financial, and medical organizations collect, process, and store unprecedented amounts of data on computers and other devices. A significant portion of the data can be sensitive information, whether that can be an intellectual property, financial data, personal information, or other types of data for which unauthorized access or exposure could have negative consequences. Organizations transmit sensitive data across networks and to other devices in the course of doing businesses, and cybersecurity describes the discipline dedicated to protecting that information and the systems used to process and store it. As the volume and the sophistication of cyber attacks grow, companies and organizations, especially those that are tasked with safeguarding information relating to national security, health, or financial records, need to take steps to protect their sensitive business and personal information. As early as March 2013, the nation's top intelligence officials cautioned that cyber attacks and digital spying are the top threat to national security, eclipsing even terrorism. The major victims of cyber attacks are the businessmen, the government officials, the banking and the financial institutions, educational institutions, media outlets, and of course the common people. Next is cyberspace. Cyberspace is actually a global domain of information systems, infrastructures including the internet, telecommunication networks, computer systems, and embedded processors and controllers. In other words, cyberspace is actually everything involving a computer.
We are connected in cyberspace in more ways than ever. The things we do using ICT are cyber activities like getting information, communicating, shopping, banking, and gaming. Significantly transformed our culture within a few decades. Over time, we have even come to depend on cyber activities to control critical infrastructures such as our transport sector and our energy supply, making cyberspace our critical infrastructure itself. However, this advance in technology is accompanied by an increase in cyber risks. All the things we connect in cyberspace are exponentially expanding the surface for attacks and incidents by ignorant users, hackers, criminals, state actors, and even autonomous system anonymity. Technologies that protect our privacy online have an obvious downside. They enable access to a vast network of untraceable online activity and facilitate hidden websites known as the dark web, where cybercrime is thriving. State actors are preparing to pursue geopolitical power through cyber intelligence and warfare operations. This sets up for the challenge to deal with the growing amount of threats, cyber incidents, and related cyber risks. For this purpose, we conceptualize cyberspace as a three-layer model. Comprised of a technical layer, a socio-technical layer, and a governance layer. Cybersecurity concerns the challenge of taking a well-balanced set of measures in all three layers to reduce cyber risks. In all cyber sectors to acceptable levels, for example, the risk of online banking should be managed by the technical layer, taking IT-related measures like strong authentication and encryption of data. The socio-technical layer taking behavior-related measures like never logging into an account, fire a link in an email message, and keep confidential information well protected. Banks and governments acting at the governance layer to enforce the measures at the technical and socio-technical layer by initiating rules, regulations, and laws. Societies all over the world collectively face a big security challenge, the challenge of securing our cyber activities. Effective cyber risk management calls for a holistic and transdisciplinary approach in which all stakeholders work together to secure cyberspace.
Types of attacks. A cyber
attack is deliberate exploitation of computer system, network, and system which is associated with technology-dependent enterprises. Or the cyber attack is a malicious code to computer code, logic, or data, resulting in disrespectful consequences that can compromise to a system, such as information and identity theft. Cyber attack may include phishing, ransom, DDoS, vectors, and by some cyber viruses. First one is by phishing. What is phishing? Phishing is a form of social engineering where a criminal hacker tries to trick the user into clicking into a malicious link or downloading an infected attachment or divulging sensitive or confidential information. What is ransom? Ransom is a type of malicious software that can be caused by publishing the victim's data or unless by removing the data of the victim with the respective use. Third one is by DDoS attacking. What is DDoS attack? A DDoS attack tends to disrespect in the web traffic and take site into offline by overwhelming a system. This can be done for two purposes. First one is for revenge, and second is for as a cyber attack or for entering into a certain organization systems. And the fourth one is viruses. The computer virus can be affected by a certain methods. The first one can be entering into some infected link, entering into some any systems like that, or attaching your system to a infected system. And the fifth one is computer vectors. So the computer vectors causes many certain forms, that is by hardware or infecting the system with malware or harvesting of data.
Some of the latest technologies used in cybersecurity. First one, hardware authentication. Hardware authentication is an approach by user authentication that relies on a dedicated physical device such as a token held by an authorized user rather than a basic password to grant access to the computer resource. Using devices and methods such as non-RIS, trusted platform modules, intrusion-aware cases, and device locks, disabling USB ports and mobile enabled access may be considered more secure due to its physical access. The coming video shows the Intel authentication solution.
Modern authentication should validate something you know, something you are, and something you have. Multi-factor authentication is supported by the latest Intel Core vPro processor-based computers to lock down endpoints against unwanted access. Computers are less susceptible to tampering when hardware, software, and firmware form an integrated security solution. New Intel Core vPro processor-based computers with the Intel Authenticate solution enhance hardware security at the deepest level by design.
Second one is user behavior analytics. User behavior analytics tracks the system's users. UBA tools is for a user specialized type of security analytics that focuses on the system and the people using them. UBA technology firstly introduced in the field of marketing in order to predict the consumer buying patterns. But as it turns out, it's also helpful in the field of security too. This technology uses big data analytics in detecting the unusual behavior of the people. And this technology is also important and helpful in finding the blind spots in business. Third-party big data. Suppose a criminal is setting up a clinic with fake doctors to get their hands in the patient's insurance IDs for sham procedures. This analytics can inform and alert the companies that these so-called clinics were set up in remote areas with low populations.
The third technology that is used in cybersecurity is AI, that is artificial intelligence. Artificial intelligence can be defined as artificial decision making, similar or equal to human decision making, related to some algorithms and mathematical calculations. Besides the role of AI is ever increasing in this virtual world, the threat to cybersecurity is also considered a serious issue. AI can be used to identify unexpected attacks on cyberspace, including web platforms and high security based official websites. Hackers use many ways to initiate cyber attacks and demand for ransom. Within this scenario, high security based websites use AI as the primary method to detect cyber attacks. So it is difficult for the hackers to hack a high security website because high security websites use AI as the method to detect any unauthorized entry. Within this scenario, AI can be used to prevent cyber attacks in many different ways. Some softwares based upon AI can be used to help the website keep away from cyber attacks from hackers as well as phishers. Another technology used in cybersecurity is machine learning. Today, it's impossible to deploy on cybersecurity without relying heavily on machine learning. With machine learning, cybersecurity systems can analyze the pattern and learn from them to prevent similar attacks and respond to changing behavior. Machine learning also helps cybersecurity systems to be more proactive to prevent threat and to respond to real-time attacks. Machine learning in cybersecurity also help some of the organizations to utilize their resources more strategically. It's about developing the pattern and manipulating those patterns with algorithms. If we want to develop the pattern, then we have to collect rich data because these data represent as many potential outcomes from as many potential scenarios as possible. It's not just about the quantity of the data, it is also about the quality. The data collected must be relevant and contain rich context collected from every potential sources. One of the biggest challenges is to collect the data from network, endpoint and cloud and normalize it into one state so that it can be used effectively for machine learning.
Now the next emerging security technology is the cloud, and the upcoming video shows how the cloud is set for cyber defense.
Cloud computing is transforming the way we do business, making IT more efficient and cost-effective. But it's also opening companies up to new types of cyber threats. Today, it's not a matter of if, but when. Mary is going on a cruise and notices the cruise line's website offers an image-sharing mobile application that is hosted on a cloud. The app will let her access her itinerary, track her trip, and share her vacation images with friends over social networks. However, after a week on board, Mary begins to feel a little uneasy, and it's not seasickness. Many of her friends have complained to her that they were spammed after viewing photos she shared via the cruise line app. She complains to the cruise director. Meanwhile, back on shore, the cruise line's development team is already aware of the problem and is working to rectify it. So how could a cruise line know about this type of breach before the users themselves are aware? And what measures can they take to both alleviate any current problems and prevent them from happening again? The best defense? A security incident response team that can quickly take whatever steps are needed to thwart attacks and restore system health. This team is on point to guard the cloud, armed with the latest software and security technology. They can tackle the full gamut of security issues through 3 important steps: monitoring data, gaining visibility in the cloud, and managing access. Let's look at monitoring data. Danielle is the cruise line's data security analyst. Her cloud data activity monitoring system notifies her that there's something fishy going on. But the system doesn't just flag a set list of threats. It can detect new types of possible security threats. It uses advanced machine learning techniques to build detailed models of normal system behavior and flags any deviations to these models, assessing the risk in each deviation. This, combined with built-in insights around known hacking techniques, enables the system to rapidly detect unusual user and database activity. Danielle goes to Ian, the enterprise security analyst. Ian is able to provide her with the detail needed to gain visibility in the cloud. He monitors all the traffic going in and out of the cloud using a variety of sophisticated software or virtualized software appliances. It detects multiple suspicious events we call offenses. All this activity is collected and analyzed within the cloud to work out not only what is happening, but who is responsible for the offense. The system basically looks for patterns. It will correlate perhaps millions of events as it searches for suspicious patterns that deviate significantly from normal system behavior. It provides the visibility to quickly pinpoint and identify the hacker's credentials. In this case, Ian and Danielle quickly realized that a group of hackers has compromised a team member's password and used it to access the cloud management console. From there, they were able to create unauthorized administrator accounts, which then introduced the malware that created the spam. To address this issue, the incident response team can remove the new administrator roles created by the hackers and change all cloud credentials and passwords. These measures thwart the hackers' malicious activity by shutting down their privileged access. To prevent further cloud breaches, Ian finally talks to Annika, the Identity and Access Architect. Annika's job is to manage access. She uses a Privileged Identity Management System, or PIM, that controls access to the critical cloud resources that store confidential and sensitive information. The PIM uses a method of checking fresh credentials in and out each time the system that Annika manages is accessed. This adds an extra layer of security for users who have the high level of access to this confidential information. All of these steps are crucial, particularly when you consider that a typical organization has 785 different cloud applications in use. But surprisingly, on average, they only know about 60 of them. The rest of the apps are unknown and unsanctioned. Security is a journey, not a destination. Security intelligence monitors data, gains visibility, and manages access in order to evolve and respond to the ever-changing world of the cloud.